probably thinking, man, who's that good-looking guy with that big haircut? Man, last time I knew he had all kinds of hair. Now I got it. Well, fine, this is what it's supposed to look like. Yeah. Don't let the lights hit it directly. Yeah, baby, here we are. Common Core, Algebra 1. Algebra 1. I teach Algebra 2. I also have taught Algebra 1 so many years. It's crazy. Algebra 1. We are doing August 2014, and we are going to do parts 2 through 4. Questions 25 through however many their problems are in this thing. And my name is Mr. Key. Actually, it's not Mr. Key. It's Mr. Krause. You can find all of this material organized very nicely for you at mrkrausemath.com. There's a link in the show notes somewhere down over there, somewhere. I don't know, somewhere down over there. Hit that like button. Give me a thumbs up. Hit the subscribe button, more importantly. The more subscribers I have, the more cool stuff I can do. It's math. It's not that cool, but maybe I can help you out. Anyway, here it goes, kids. Here comes the lecture. Now, before I lecture my students, I like to take a little bit of cup of coffee. My own students think I put stuff in there. The only thing I put in there is cream and sugar. Not weird stuff, but just cream and sugar. At any rate, if you're here to cheat because you're too doggone lazy to do the work yourself, hey, no problem. Hope you enjoy Algebra 1 next year. And if you're the one, I ain't gonna repeat Algebra 1. I'll go to Algebra 2. I'm gonna go to geometry next year. Yeah, well, whatever. You'll just not do very well. The world does not need mediocre people anymore. We have enough mediocre people. We need inspiring, awesome people. So if you're here because you've already done the work and you're just here to see if there's another way to do the problem, that's great. But Algebra 1 is not that difficult. You can handle it. Try it on your own. Get her done. Okay, kids? We are going to number 25. Hey, I guessed right. Problem 25. Here we go. So I will try to show you a couple different ways to do it. I want to make sure you understand things, though, kids. All answers should be... For all questions in this part, a correct numerical response with no work will receive credit, only 1 credit. You have to show work. We have to show work with my cool blue pen. All right, so here's a dumb way of saying, hey, let's factor this puppy. I don't even understand this question. It's a weird question. All they're asking you is factor it. So let me factor it. X plus 4, X plus 6. And since B is this value, it looks like B can equal 6. But wait a second, there's this thing called the commutative property of multiplication, which says that I can multiply like that, or I can multiply like this. So B can also be 4. So the values for B are 4 and 6. Woo, look at those curly brackets. That's terrible. That's terrible. Just totally embarrassing. Mediocre. Mediocre at best. All right, that's not good either, but we'll just move on. Those are the 2 answers. That's it. All possible values of B. Those are the 2 answers you can get. Rhonda deposited $3,000 in an account earning 4.2%. This is the hard part about these problems. We're compounding annually, and she wants to know her balance after T years. So this is that equation that says, by the way, do you see this word equation? If you don't have an equal sign and you just have an expression, even though it's perfect, you don't get any money. So this is those ones. I'll just do f of x. It really makes no difference. Actually, we got to do f of t since we're going to call it t. F of t is equal to a sub 0 times 1 plus or minus my percent raised to the t. Now, it's plus if it's increasing, and it's minus if it's decreasing. So, and a sub 0 just stands for my original amount. So, my function at t, you could probably have y equals as well, is going to start with $3,000. We're going to do 1 plus. Now, 4.2%, kids, 4.2%. Let's say 10% is equal to 0.10. So 4% would be equal to less than this. You can't have 0.4. That's 40%. Be careful. Anything less than 10, it's going to be equal to 0.04. Now I don't have 4%. I have 4.2%. So see how the 2 comes after the 4? So here we're going to go 0.04, that's 4%, and then that would be 4.2%. So that's the number. That would be the tricky part. Hopefully my big head's out of the way. There it is, 4.2%, 0.04. At any rate, we're going to put that in here, 0.042 raised to the t. That's all they want is the equation. Now, if you did this, if this was your answer, that's not an equation. This has no equal sign. So if this is a 2-point question, you got a 1 out of 2, and I know you can do the math, that's a 50%. 50% on a problem you got all the cool hard stuff done on, but you forgot to make it an equation. So f of t or whatever. There it is. Moving on to 12, kids. So Gary and Jim, oh, it's Guy and Jim. Guy and Jim, some guy named Jim. No, Guy and Jim are paid $185 plus 3% of his sales, X, which can be represented by that. Jim is paid $275 plus 2.5%, which can be represented. Determine the amount of value of dollars that they make when they have the same. The same is another way of saying equal. So really all they're asking to do is solve an equation where those two, Guy is equal to Jim. When do Guy and Jim equal each other? Forgot the M. So Guy is 185 plus 0.03x. When does it equal Jim? And Jim is 275 plus 0.025x. Since this is the smaller x value, I'm going to subtract this one. And I'll show you all the steps just so you guys can get used to it. And let's see, we're going to go 185 plus, what is this, 0.005? I think that's 0.005x equals 275. Subtract 185. Subtract 185, and I get 0.005x is equal to 0. 27 minus 18 is 90. Divide by 0.005. Divide by 0.005 is going to be somewhere around 1,800. No, 18,000. I think it's 18,000. But let's just check. Let's first make sure I got 0.03 minus 0.025 right. Yep, 0.0225. And then we'll take 90 and we're going to divide it by that number. And we get $18,000 in sales. So the question says is, determine the value of X in dollars that will make their weekly pay the same. Okay, so X is equal to 18,000 buckaroos. There she rolls. Yay, that problem's done. Moving on to 28. Ka-ching, ka-ching, ka-ching. Blow this up. Ooh, what happened? There we go. Express. Oh, product. You have to know this vocabulary. Gosh, I can't tell you how many kids I say, oh, what does product mean? Equals? Huh? What? It just means multiplication. So we're really taking this thing and multiplying it by this thing. Let's pick a new cool color. How about purple? So we're going to take 2x squared plus 7x minus 10, and we're going to multiply it by x plus 5. All right, we're going to pick like 3 different colors. So first we're going to go this one times both of these. So we get 2x cubed plus 10x squared. New color, green. 7x times both of these. And I get plus 7x squared plus 35x. And orange, negative 10 times both of these. So that's negative 10x minus 50. So let's clean it up. We get final answer of 2x cubed plus, put these two together, 17x squared, put these two together, plus 25x minus 50. Ka-ching. That's it, kids. That problem's over with. All right. Come on. It's going left and right, but it won't let me go up and down. Come on. Ah! That's the function f. let G be the function such that G of determine which function has a larger maximum value. Maximum values are Y values. So if I come up to this one and I say, okay, your maximum value is right there. And that point is 1, comma, 1, 2, 3, 4, 5, 6. 1 comma 6. So f of x has a max value of 6. G of x has a max value of, well, I don't know. So what we will do is we have to justify our answer. So I'm first going to show you how to do this electronically. We're going to go over to this thing, and I'm not really sure what the rubric said that year as far as what they would take. So we're going to graph this. It's negative 0.5 x squared plus 4x plus 3. So we're going to graph that, and we're going to find the maximum. So I'll just drag down. I want to find that maximum, that point right there. So I'll go to menu. Let's see. 5's good. We'll just trace. Graph trace. We'll just use graph trace. Graph trace is nice because it'll actually tell you when you have the maximum. There it is right there, maximum, 4 comma 11. So this one has a max value of 11 since the vertex is 4 comma 11. Now, found on my calculator. Now, this is only a 2-point question, so I'm guessing as long as I actually answer the question, I'll be done. I haven't yet answered the question. It says determine which function has the larger maximum value. Then I would say therefore g of x, yes, that stands for therefore, g of x has the larger maximum value. Okay, so having done that, let me show you the algebraic way, because your teacher may ask you to do this by algebra. So if I go back to what g of x is, f of x is easy. It's just whatever that maximum vertex is. But g of x, we got a little bit of work to do. And it's negative 1/2 x squared plus 4x, I don't remember what it was, plus 3. It really doesn't matter about this. Plus 3. The maximum is found, the max or min are always found at the vertex. The vertex is the axis of symmetry, comma, y value of the axis of symmetry. So in order to find the actual vertex by algebra, you have to do the axis of symmetry. Let me bust out the red pen for this. X equals negative b over 2a. That's the axis of symmetry. So if I want to do that, it's negative 4 divided by 2 times negative 1/2. So this is negative 4 divided by negative 1, which is just 4. Now what you do is you plug that value into the equation. You want to figure out what g of 4 is. So it's negative 1/2 times 4 squared plus 4 times 4 plus 3. Now this I personally would just put into my calculator, and I would get 11. So the vertex is 4 comma 11. So this is the max value. So that's the algebraic way of doing it. Either way is fine. I think either way would have given you full credit. All right. So it says solve the inequality and determine the smallest possible value for x in the solution set. So we're looking for a very small number, or as small as we can. Thanks. Double D's, Dunkin' Donuts. Oh, yeah. All right, so let's distribute. We get 3x plus 9 less than or equal to 5x minus 3. We'll subtract 3x. They tried to trick you a little bit here. They tried to trick you. They tried to do it a little bit. And I get 9 is less than or equal to 2x minus 3. We'll add 3 and bring that over, so we get 12 is less than or equal to x, 2x. And then x divided by 2, x is greater than or equal to 6. Now, the reason they tried to trick you is because that's not the way we're used to seeing it. We're used to seeing it like this. X is greater than or equal to 6. Notice the wide part is still pointing towards the x. So what this says is x is greater than or equal to 6. I want the smallest value. The smallest value that x can equal is 6. Done. All right, this next question was kind of rinky-dinky crazy. So the first thing they want you to do is plot these points. Now, unfortunately, very difficult for me to actually see the points and plot them at the same time. So let's see if I can get in this. So I'm going to plot the point 2, 2, and 3, 1. So I probably should put a scale on here. It doesn't really have a scale on here, does it? No scale. So I'm going to put a scale on here. By the way, if the scale is just 1, 1, you don't really have to put a scale. So I'm going to plot the point 2, 2, and 3, 1. 2, 2, 3, 1, 2, 3, 1. And I think the next one's 3, negative 1. Then I'm going to plot, oh, I got them right here. I got them on my other piece of paper. So I'm just going to look at them on my other piece of paper. 4, negative 2, 4, negative 2. Now, if this is a linear function, if this is a good linear line of best fit, then what we don't want to see is, we want to see no pattern. We want to see no pattern at all. So these residuals are how far away they are from the line of best fit. And if there's a pattern, then it means that really there must be a better way, not a linear line of, not a linear best fit line, but you're probably looking more of a regression with a quadratic or cubic or something like that. I know this is a little bit higher level thinking. I hope your teacher did a decent job talking about residuals, but the thing is about these is you're looking for no pattern. The next one would be 6, negative 3. That was 4, negative 2, 6, negative 3, 7, negative 2, 8, negative 1, 9, 2, 9, 0, and 10, 3. So the problem with it, this one is, do you see how we have like a parabolic shape here? So I don't care if your parabolic shape's that way or parabolic that way. If there's a pattern, then that means that a linear fit is not the best answer. So these residuals, a line of best fit would not be appropriate because the graph of the residuals has a distinct shape. If it's random and going all over the place, or it's more, you're just looking for not that shape. Anytime you have a distinct shape or some kind of distinct shape with the residuals, you want to eliminate that as being a choice for linear. That's about what you got to remember for that. All right, let's get to more math. Well, you probably noticed two things. One, the audio was getting really bad on that last problem. And two, I've changed shirts. And so what I'm doing is I'm redoing these problems from 32 on. It's a lot of fun to redo them. Well, the audio was so bad I couldn't have you guys sit through that. That's unprofessional. So anyway, here we go. Let's get started. Let's get Roddy to rock and roll. We're on problem 32. Let's see. A student was given, I got to do these equations again. I got to reread them. By completing the square. The first step he did was bring the 13 over. Nice job. The next step the student process was to add C. Now, I always put a square here and a square here. So whenever you see me do the completing a square, I put those numbers in squares. State the value that C represents. So what I like to do is this. Is equal to 13 plus square. Now, the square represents the constant that I'm going to put on both sides. So here's how it works. You always put x, copy over the sign, because it's half of positive 6. And half of positive 6 is positive 3. Then we take positive 3 and square it to go here. So that would be 9. And if I add 9 there, I got to add 9 there. So C equals 9. Not a big shake, not a big problem. Remember, this is only a 2-point question, so there's not a lot of things you have to show here. Explain how the value of C is determined. The value of C is determined by taking half. How about half? Half, H-A-L-F, half of the linear term, of the linear, or if you want, middle. They probably didn't care if you said linear, but the x, since it's just x, it's linear. The middle term and squaring it. That number is added to both sides. Is added to both sides. All right, I guess that's about it. That's about all that problem had into it. Whew, that's pretty easy. Hopefully you know how to do completing a square. All right, another one that's not too bad. But we are on 4-point questions now. So 4-point questions are going to require a little bit more work and a little bit more thinking. So the first thing they want us to do is graph this. And again, if you've forgotten what the graph of an absolute value function comes in, graph the thing. Take a look at it. You know, absolute value of 3x. Boom. There's what it looks like. When you're done, your graph should look like. If you don't know what the table of values looks like, come over here, hit Control-T, and find all the values that will work. The lowest one you're going to be able to do is negative 3, 9. So we'll just go x and y, negative 3, 9, negative 2, 6. This is what would be in that table. Negative 3, 3. Nope. Oh, this should be negative 1, 3, 0, 0, 1, 3, 2, 6, and 3, 9. You got to graph them. Should look like a V, nice narrow V, because it's got a dilation of 3. It didn't give you a domain, so you have to use arrows at the end. Otherwise, it's an inaccurate graph. Holy mackerel. Okay, even that's bad for me. Let's see if I can do this better this time. It's very difficult. I don't know why. Maybe going this way is more difficult than going the other way. Well, anyway, that's the graph. Let's see what else they ask us. So if g of x is equal to f of x minus 2. So notice there's two things I can do. I can add or subtract on the inside of the parentheses, or I can add or subtract outside of the parentheses. When you add or subtract on the outside, this is a vertical. If you don't like the word vertical, it's an up-down shift. This one is a horizontal shift. Taught my students how to remember horizontal. It's lying down. There it is. Sorry if you don't like that. Anyway, it's a horizontal shift left or right. Now this one is normal. What I mean by normal is if it says minus 2, it's going up, down. If it's plus 2, it's going up. This one is backwards. So if I subtract on the outside of the function f of x, this will be a translation down 2 units. So f of x is translated down 2 units. In this one, f of x is translated right 4 units. Right, it's backwards. Even though it says minus, it's going right. That's it, kids. That's all you got to remember about that. All right, I'm going to pause. I'll come back. Unfortunately, what I have to do is I have to go through like 2 problems and then take a break and then go through 2 problems and to break a break and then go through 2. Okay, so express B1 in terms of A, B, AH, and B2. So I'm going to do this 2 different ways because you might have 2 separate answers. So let's start. I'll do one way in purple and I'll do one way in a different color. 1/2 H B1 plus B2. I'm going to do it my favorite way first, and then I'll do it my unfavorite way. My favorite way, first of all, is to get rid of that ridiculous 2, or 1/2. The way to get rid of a half is to multiply this side by 2 and multiply this side by 2. Now, if you multiply this side by 2, the 2 and the 1/2 cancel, and you end up with 2a is equal to h times b1 plus b2. Now I want to get rid of that h, so I'm going to divide by h. I'm going to divide by h. So I get 2a over h is equal to b1, those cancel, b1 plus b2. I guess I'm doing this in black. And I said this wants to solve for b1, so we got to move b2 over. Minus b2, minus b2. So I get 2a over h minus b2 is equal to b1. So that is one acceptable answer. Another way to do this problem, let me start it out again. A equals 1/2 h b1 plus b2. You really should get rid of the 1/2 first. Multiply both sides by 2. So I get 2a equals h times b1 plus b2. Distribute the h. Some people distributed the h. Gosh, why do I keep doing that? H b1 plus h b2. Okay. Then I'll subtract h. What am I going to solve for b1? So I'll subtract hb2 minus hb2. So I'll bring this one over to the other side is equal to hb1, and then I'll divide by h. So another acceptable answer would be b1 is equal to 2a minus hb2 all over h. Whatever. Either way is fine. I'm going to use this one down here. So I'll rewrite that. b1 is equal to 2a over h minus b2. It said the trapezoid area is 60, so that's going in for area. Its height is 6 feet, that goes in for height, and one of the bases is 12. What's the other base? All right, it's pretty straightforward. b1 is equal to 2 times 60, all over the height, which was 6, minus 12. So b1 is equal to, let's see, 6 goes into 6. I would just type this all in my calculator, but I'm going to do it here. 10. So that's 20 minus 12, which is 8. So the answer is 8. Now I can check this by going back up here. If I want to, go back up here and use that area formula. Now remember, the area formula of a rectangle is, or a trapezoid is 1/2 the height, which they said was 6, times the sum of the bases, b1 plus b2. Well, that would be 12 plus 8. And hopefully this is equal to 60. So 1/2 of 6 is 3. Those two added together gives me 20, and that's 60. And that's what they said. I'm done. All right. Let f of x equal that parabola and g of x equal that linear function on the set of axes. So what I would do is I would graph x versus f of x in one color. So let's see. If you graphed it, you should know that it's a relatively skinny upside down parabola. So negative 2x squared. It should be a relatively skinny upside down parabola. You can go to the table of values, Control T, and you can look. Let's see. The lowest number I can use is -2, -8. So I'll go -2, -8, -1, 0, 1, and 2, and this will be also -8. 0 would just be 0, and if I put in a 1, this should be -2 and -2. And you can check your work, -2 and -2. All right, so I'll plot those first. -2, -8. 0 or -1, -2, 0, 0, 1, -2, and right here. And down, and then and down. Okay. Now the next one is just a straightforward linear function. I'll do this in a different color. We'll do this in red, I guess. And this is y equals 2x minus 4. Now, I don't really necessarily need a table of values for this one. It's -4, 1, 2, 3, 4. And the slope tells me to go up 2 and over 1. Well, there's one of my points of intersections. Up 2 and over 1, over 2 and over 1, down 2 and over 1, down 2 and over 1, down 2 and over 1. And I should graph that line. Oh, not bad, not bad, not bad. You should label at least one of them. So y equals 2x minus 4. If they're done in color, generally they're supposed to say -2x squared. They're supposed to say you're fine because the color signifies the labeling of them. The question says is, use this graph to determine and state all values for x which the two functions are equal. So they want to know the x values for which these two functions are equal. Let me find the 2 points. The 2 points are -2, -8, and +1, -2. So determine and state all values of x. So the answer is, for this case, is just the x values. So your x values are -2 and 1. Those are the two answers to that question. Boom. Shakalaka. All right. Bye. I'll be back. Can I tell you, I am enjoying doing these twice. This being the second time I've done these, because it's a lot more fun the second time around. All right, I think we got 2 problems left, 36 and 37. So I'll do 36, take a break, 37. Now the break takes me about 2 minutes to do some work, but it's no big deal, kids. I'm enjoying this. A school is building a rectangular soccer field. Can't think of anything better. It's got to have an area that has an area of 6,000 square feet, and it must be 40 yards longer than its width. So let's do that. So if my width, I'll call my width W, then my length has to be, and you should only really use my one variable, my length has to be 40 yards longer than that. So that's got to be W plus 40. W plus 40. That would be 40 yards longer. Determine algebraically the dimensions of the soccer field. This is a 4-point question. Okay, kids, this is a relatively simple question. In order to find area, it's equal to length times width. So we're going to use that idea. We're going to take the W, the width, we're going to multiply it by the length, and it has to equal 6,000. Maybe because they gave us the number 6,000 and that's such a crazy bad number. So we'll do W squared plus 40W equals 6,000. We'll bring the 6,000 over, so I get W squared plus 40W minus 6,000 is equal to 0. And now I have to factor it. And maybe that's the hard part about this thing, factoring it. Although I do know it's W, and one's plus and one's minus. I'll bring 6,000 over here. It's actually negative 6,000. Let's see. How about 20 and 30? 20 times 30, 2 times 3, that's 600. So 20 times 300. 2 times 3 would be 600, 6,000. That would be 6,000, but they're not 40 apart. How about negative 30 and 200? That would be 6,000, but they're still not 40 apart. How about negative 40 and 150, I think it is, right? 150. Let me make sure. 40 times 150. 40 times 150. 6,000. But they're not. That's not going to work. 50 and 120, but they're not 40 apart. Negative 60 and 100. There it is. And it really was that hard of that. I mean, I could have gotten there right away, right? 100 minus 60 is 40. There they go. Negative 60, positive 100. So my W, my width can be equal negative 100, which is stupid. Doesn't make any sense. Get rid of it. Or my W can equal 60. So the width is equal to 60. And the length, which is 40 more than that, would just be the 100. So the length is equal to 100. That was a simple question. And then they get to this question. I think they gave you that easy one because then they decided to give you a zinger, Zamboni question. 6 points. Okay, guys, there's lots going on in these 6-point questions. So let's talk about Edith. Let's talk about Edith. Let's talk about You guys, you know that song. It's a cool song from like really old away, and it's really not that cool of a song. So let's see what we got. Edith babysits for X hours a week after school. That only pays her $4 an hour. She's accepted a job that pays $8 an hour at the library, working Y hours. So we've got X for babysitting and Y for the library. She will work both jobs. She is able to work no more than 15 hours. No more than means less than or equal to 15 hours due to school commitments. She also wants to make $80 a week, working a combination of both jobs. Let's state a linear system of inequalities that can be used to represent it. Okay, so the first one's pretty easy. It's X plus Y. This is the number of hours worked, and she can't work more than 15, so that has to be less than or equal to 15. So that's the hours. This is the hours. Now we're going to talk about money. So she makes $4 babysitting, so 4X. And then we're going to add in the amount of money she makes from working at the library. That's $8 an hour times Y. And this has to be more than or equal to, so that's at least greater than or equal to $80. So there's my system of inequalities. Now, it doesn't say you have to do anything past that, but there's my system of inequalities. So that answers the first part. Then they want you to graph them. Now, in order to graph these, we're going to have to solve for Y. Well, this one's not bad. We'll do this one in purple. Y is less than or equal to. When I bring that X over, it becomes negative X plus 15. So we'll do this one in purple. So there's 10, 11, 12, 13, 14, 15. And the slope is -1, so we're just going to come down. Now, because it was equal to, when I go to draw my line, I'm going to draw, which I know I'm going to not be able to do. I'm going to draw a nice, solid line. It's much better, actually, than I thought I was going to get. And ding, 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 and ding, and now, because this is an inequality, first of all, you have to stop there, no arrows. But because this is an inequality, I have to do shading. And we said less than this. So we're going to shade down. All right, that's the first part. Now the second one we're going to do in red. So let me do that one. That one's going to be a little bit more work. This one is 4x plus 8y is greater than or equal to 80. I'll bring the 4x over. I get 8y is greater than or equal to negative 4x plus 80. We'll divide by 8, and I get y is greater than or equal to, now negative 4 over 8 is really negative 1/2 plus x plus 10. So this one's going to have a y-intercept that's 10, but a slope of negative 1/2. So we're going to go down 1 to the right 2, down 1 to the right 2. Now this is the boundary line for how much money she wants to make. We need to be greater than that. So we actually need to shade up here. And you should label one of these. I'm going to label this one y is greater than or equal to negative 1/2 x plus 10. Was it 10? That seems wrong. Yep, 10. All right. So continue on to the next page. The next page says, determine and state one combination of hours that will allow Edith to make $80 an hour while working no more than 50 hours. So I'm going to come back to my graph. I'm going to come back to my graph, and I'm going to find one point where it works. Wait, let me see, make sure I've answered these. Graph inequalities. Okay, so I need to find one point where it works. Now, remember, she has to work both. So I'm just going to pick one right here, right in the middle. And that would be 2 hours. Now, this is the x-axis, just 2 hours babysitting and 11 hours working at the library. So when I come over here, determine and state one combination of hours. So 2 hours babysitting. That would earn her $8, right? 2 times 4. And 11 hours at library. And that would make 11 times 8, which would be 88, for a grand total of $96. That's it. I think that's it. That's all they wrote, right? There's nothing else after that, right? Big old page for nothing. All right, kids, that's the end of that test. I hope you guys did okay. I hope you guys crushed it. I hope we rocked it out of the park. I can't find my button. Bye. See ya. Catch you on the flip side. Bye.